Good day everyone, my name is Ray Benting Flores and welcome back to my YouTube channel. Last, in my previous videos, I have already presented to you the basic integration, and if you haven't seen that video, I am including the link in the description box of this video. I am saying those because for today's video, we will be discussing about an application of integrals, and it is another way to integrate the given function, especially if it involves trigonometric functions. So before we dig into the main topic for today, we will be first review ourselves about basic integration. So of our first review example is the integral of sine cube x dx, and we all know that sine cube x dx is equal to sine squared x sine x. And if you are familiar with the identity cosine squared x plus sine squared x is equal to 1, we just simply apply additive inverse in that particular identity. So we came up with 1 minus cosine squared x sine x. So if we distribute sine x, or if we multiply sine x to 1 and then to negative cosine squared x, we will have this new given, which is the integral of sine x dx minus the integral of cosine squared x sine x dx. And if we integrate that function, we will have this result: the negative cosine x plus 1 over 3 cosine cube x plus c. So let us remember that in derivation, the power rule is to subtract 1 from the power. However, in the integration or integral, we are doing the opposite thing. We just need to add 1 to the power and make it our denominator. So the second review example is we have the integral of cosine 2x dx, and we'll let u be equal to 2x and our du be equal to 2 dx. And our dx, we just simply apply multiplicative inverse to our du. So we came up with 1/2 du as the value of our dx. So we have this form as we use those variables that denotes a certain value from the given, the u, du, and the dx. So we have this, the integral of cosine u, 1/2 du. Since 1/2 is constant, we just exclude it from the integration. So we have 1/2 the integral of cosine u du. And as we integrate the cosine u, or the integration of cosine u du, that will be equal to sine u, and then multiply to 1/2. So we have 1/2 sine u plus c. We all know that u has a value, and that is 2x. We just simply plug 2x as to substitute the value of u. So we have 1 over 2, or 1/2 sine 2x plus c. So this is now our main topic, which is entitled Products and Powers of Trigonometric Functions. It is trigonometric integrals. So the objectives of this video is that at the end of the lesson, the learner should be able to first discuss integrals involving power and product of trigonometric functions. Second, familiarize some trigonometric identities. So in integrating products and powers of trigonometric function, this is the identities, or the formula we should be familiar. First is the integral of cosine powered n, or cosine raised to the power of m, x sine raised to the power of n, x dx, where m and n is positive integers. Second, we have the integral of tangent mx, second nx dx, where m and n is positive integers. These two first identities is focusing more on the powers of trigonometric functions. And the third one, or the last one, focusing to products of trigonometric functions, which is if m and n integers are integers with m is not equal to n. So we have three products trigonometric functions identities. First is the integral of sine mx, sine nx dx. Second one is the integral of cosine mx, cosine nx dx. The last one is the integral of sine mx, cosine nx dx. So let's do some examples. In solving in solving in integrating power and product of trigonometric functions, we have three cases to consider. If the power are both even, and if the power are both odd and alternate, or one odd and one even. So first example, we have this integral of cosine raised to the power of 5x sine squared x dx. So as you remember in our review example, we have we just simply do the exact thing. We just find the value of cosine 5, cosine raised to the power of 5x, which is, we all know that it will be equal or the same to cosine raised to the power of 4x cosine x. And as we rewrite cosine raised to the power of x, we can simply rewrite it into cosine squared x, quantity squared, cosine x, and the same identity, which is cosine squared x plus sine squared x is equal to 1. We just apply additive inverse by adding negative sign both sides. So we came up with 1 minus sine squared x squared cosine x. And just combine it to sine squared x, the remaining given. So we have this new form of given, which is the integral of sine squared x, the quantity of 1 minus sine squared x squared cosine x dx. And from that, we are now able to integrate the given function. We let u be equal to sine x, we let du be equal to cosine x dx, and then we just rewrite the given using the two variables that denotes a certain value from the given. So we have the integral of u squared, quantity of 1 minus u squared squared du. First, we just squared 1 minus u squared. So we have the integral of u squared, a quantity of 1 minus 2u squared plus u raised to the power of 4 du. And then substitute the value of u squared to the quantity. So we have u squared multiplied by 1, so u squared multiplied by negative 2u squared. So we have negative 2u raised to the power of 4 plus u squared multiplied to u raised to the power of 4, so we came up with u raised to the power of 6 du. As what I have said in integration, we just add 1 to the power and make it our denominator also. So as we integrate that given, we just simply has these values. We just have u cubed all over 3 minus 2u raised to the power of 5 all over 5 plus u raised to the power of 7 all over 7 plus c. And since we all know that u has its value, which is sine x, we just plug sine x to substitute the variable u. So we came up with 1 all over 3, or 1/3 sine cube x minus 2/5 sine raised to the power of 5x plus 1 over 7 sine raised to the power of 7x plus c. Sorry for the inconvenience to not show the whole results. So the second example is we have the integral of cosine cube x sine cube x dx. The same process, we just simply find the value of sine cube x, which is equal to sine squared x sine x, and then just disregard the cosine cube x for now. So we all know that sine squared, applying this identity, is cosine squared x plus sine squared x minus is equal to 1. We just again apply additive inverse by adding negative cosine both sides. So we came up with the quantity of negative quantity of 1 minus cosine squared x sine x combined to cosine cube x. So we have now the integrals of cosine cube x, the quantity of 1 minus cosine squared x sine x dx. So solving this will let u be equal to cosine x, du be equal to negative sine x dx, and we have to rewrite the given using the variable that denotes a certain value from the given. So we have now the negative integral of u cube quantity of 1 minus u squared du. We write it, so we came up with the integral of u cube um, is quantity of u squared minus 1 du, and then substitute or distribute rather the value of the u cube into the u squared minus 1. So we came up with the integral of the quantity u fifth or u raised to the power of 5 minus u raised to the power of 3 du, and as we integrate that, we came up with u raised to the power of 6 all over 6 minus u raised to the power of 4 all over 4 plus c. And since u has its value, which is cosine x, just simply substitute the value of cosine x to the variable of u. So we came up with 1/6 cosine cosine raised to the power of 6x minus 1/4 cosine raised to the power of 4x plus c. Next is we have the third example, which is the example number 3, the integral of tangent cube x secant cube x dx. We all know the value of tangent cube x secant cube x is equal to tangent squared, or the same with tangent squared x secant squared x secant x tangent x. The value of tangent squared is equal or the same with the same identity we have used to cosine and sine. So we came up with secant squared x minus 1 secant squared x secant x tangent x, and that will be our new given, the integral of the quantity secant squared x minus 1 secant squared x secant x tangent x dx. Will let u be equal to secant x, du is equal to secant x tangent x dx, and we just simply rewrite the given function using those variables of u and du, denoting the certain value from the given. So we have now the integration of u squared, quantity of u squared minus 1 du, and then distribute u squared into u squared minus 1. So we came up with the integration of the quantity u raised to the power of 4 minus u squared du. And as we integrate that, we came up with u raised to the power of 5 all over 5 minus u raised to the power of 3 all over 3 plus c. And knowing that u is equal to secant x, we just simply plug the value of u. So we came up with this result. 1/5 secant raised to the power of 5x minus 1/3 secant raised to the power of 3x plus c. Now, we will now proceed to the product rule, where m and n are integers with m and n is not equal. But in product rule, we could simply use or transform it to sum rule. From the integral of sine mx sine nx dx, we have now 1/2 cosine m minus n x minus cosine m plus n x dx. The second one is the integral of cos cosine mx cosine nx dx, and that would be transformed into 1 half cosine m minus n x plus cosine m plus n x dx, and the last one is the integral of sine mx cosine nx dx transform into 1 half sine m minus n x plus sine m plus n x dx. So this will be the example. We have the example integral of sine 3x cosine 5x dx. This is the formula we could use since it involves the trigonometric ratio sine and cosine. So we have now sine mx cosine nx dx into 1 half sine m minus n x plus sine m plus n x dx. Just rewrite it using the given values of m and x. So we have now 1 half the integral of sine 3 minus 5x plus sine 3 plus 5x dx. So we came up with 1 over 2 or 1 half the integral of sine negative 2x plus sine 8x dx. So we have now 1 half sine 8x plus sine negative 2x, which is rewrite it and then integrate the sine 8x. So we have now 1 over 8 cosine 8x plus cosine 2x as the integration of sine negative 2x. So as we distribute 1 half or multiply to 1/8 cosine 8x plus cosine 2x, we came up with negative 1 over 16 cosine 8x plus 1 half cosine 2x plus c. And that would be equal, and that would be all for today's video. Thank you and God bless. So if you want to try yourself, just try this skills exercise given. One for the power and one for the product of trigonometric functions. Bye bye. Thank you.